Good morning, everyone. Thank you for joining us today. In our last deep dive, we really got into the weeds on the dark side of AI, talking about the serious challenges of deepfakes, disinformation, and deception. It was a heavy but necessary conversation. So today, we're flipping the script. We're moving on from the problems and diving headfirst into the solutions. The big question is no longer just how do we defend against bad AI, but how do we proactively build a better, more trustworthy AI future from the ground up? This is our look at the road ahead. So here's our roadmap for today's discussion. First, we're going to talk about building AI that can bend without breaking, what we call resilience. Then, we'll get into the absolute necessity of embedding ethics right into the code itself. After that, we'll look at the future of keeping these systems in check by automating accountability. Then we'll get to the really exciting part, showcasing AI for social good, which is, the whole reason we're doing this. And finally, we'll tie it all together to define the ultimate goal of this entire effort. Let's jump right in.
All right, our first section is all about a huge mental shift. For way too long, AI security has been this reactive game. We build a wall, someone finds a way over it, we build a higher wall. But what happens when the threat is something completely new, something we never could have predicted? That's why we need to evolve from building brittle defenses to designing systems that are proactively resilient from their very core.
And that brings us to a really important question. We hear these terms thrown around a lot. So what exactly is AI resilience? And more importantly, how is it any different from the classic engineering idea of just making something robust? Understanding this difference is absolutely key to everything we're going to talk about today.
Okay, so let's break this down. Robustness is all about withstanding things you can predict. Think of a bridge. It's engineered to handle specific known forces, right? Like wind speeds up to 150 kilometers per hour. It's tough, but its strength is defined by what we already know. Resilience, on the other hand, is all about adapting to the unknown. The power grid example here is perfect. A tree falls on a line. That's an unexpected event. A resilient grid doesn't just crash. It intelligently reroutes power around the problem, containing the damage. It adapts on the fly. So AI resilience isn't just about being tough. It's about being smart enough to handle curveballs you never saw coming.
Now, if you take that idea of resilience and crank it up to 11, you get something even more powerful. It's a concept from the author Nassim Nicholas Taleb called anti-fragility. An anti-fragile system doesn't just survive stress, it actually gets stronger from it. And the best example in the entire world is our own immune system. You get exposed to a new pathogen, and your body doesn't just fight it off and go back to normal. No, it learns, it creates antibodies, and it comes out the other side stronger and better prepared for the future. That's anti-fragility. And that's really the dream, isn't it? This quote nails it. Building anti-fragile AI is our North Star. We're not just trying to build AI that survives an attack. We want to build AI that learns from that attack, that evolves its own defenses, and becomes more capable because of it. It's a total shift in perspective, seeing chaos not as a threat, but as an opportunity for the system to grow.
So that all sounds fantastic as a philosophy, but how do we actually build it? What are the real, practical, in-the-trenches tools and engineering techniques that let us turn this idea of resilience into code? Let's get into the toolkit.
So we have a few key strategies. First up is graceful degradation. This just means your system shouldn't have a single point of catastrophic failure. Think about an autonomous vehicle. If a key sensor fails, you don't want it to just stop dead in the middle of traffic. A resilient design means it recognizes the failure, slows down, puts on its hazards, and safely pulls over to the shoulder. It loses some function, but it does it safely. Second, we've got chaos engineering, which was famously pioneered by Netflix with their Chaos Monkey. You literally inject random failures into your own system on purpose to find the weak spots before a real-world problem does. And third, adaptive defense. This is where we get really close to that anti-fragile ideal. This is where a system can detect a brand new type of attack and automatically create a digital antibody for it, a new rule or a new filter to neutralize that threat on its own.
Okay, building a system that can take a punch is a massive step. But you know what? It's only half the story. A system can be incredibly resilient and still do a lot of harm if it's not built with the right values. And that brings us to our next big topic, making ethics a core part of the architecture, not just some checklist you fill out at the end.
So this leads us to a really central question in our field today. What does it actually mean to build ethical AI by design? It's a phrase we hear all the time, but what does it look like in practice when the rubber meets the road? Let's unpack that.
I absolutely love this quote because it just perfectly illustrates the problem.
For too long, ethics has been treated like a final inspection, but by the time a system gets to that point, the most important decisions about the data, the architecture, the goals, they're all baked in. Trying to fix a deep-seated bias in a model that's already been trained? It's pretty much impossible. It really is like trying to add earthquake proofing to a skyscraper after it's already built. The foundation itself is the problem.
The answer is a concept we borrowed from software development called shifting left. It just means you move the important checks to the very beginning of the process. So for AI ethics, that means at the ideation stage, before you even write a line of code, you have to ask the big question, should we even build this thing? Who could it possibly harm? Then, during data collection, you do your bias audits first, not after you've already used the data. And in the model design phase, you're consciously thinking about the trade-offs between a super complex black box model and one that's easier to interpret and explain.
So, if we're putting ethics at the start, we also need ways to actively hunt for potential problems before they ever see the light of day. It's not enough to just have good intentions, right? We need a systematic way to stress test our AI for ethical weak points. So how do we do that?
The answer is a practice called ethical red teaming. It's basically taking the idea of a cybersecurity red team, where you hire experts to try and break into your system, and applying it to ethics. An ethical red team's job is literally to think like a bad person. Their goal is to find all the ways the system could be misused to generate toxic content, harass people, or just cause harm. By finding these problems in a safe, controlled way, we can figure out exactly where we need to build better guardrails and safety filters before the product ever gets released.
Okay, so we've talked about building resilient systems and ethical systems. But how do we make sure those principles are actually followed and monitored when you've got hundreds of models running across a huge company? This brings us to the future of AI governance, which is really the enforcement arm for all the ethics we've been talking about.
So what does that future actually look like? Well, the old way of doing things, manual audits, quarterly reports, big binders full of policies, it's just too slow. It can't possibly keep up with the speed of AI. The governance of tomorrow has to be just as fast, just as automated, and just as data-driven as the AI it's overseeing. This slide really shows the paradigm shift we're talking about. We are moving away from the world of slow, periodic, manual audits, which only give you a snapshot in time, to something called governance as code. This is a pretty revolutionary idea. Instead of having an ethical policy just sitting in a PDF on a server somewhere, you translate that policy into automated, runnable code that can constantly test your AI systems against that rule. And this all leads to the ultimate vision, which is basically using AI to govern AI. Picture an AI auditor bot. This thing would be like the central nervous system for a company's AIRisk. It's watching every single model 24/7, running constant checks for fairness, security, and bias. The second it finds a problem, boom, an instant alert goes out. It effectively becomes an organizational immune system against risk. And you see how this ties back to our earlier idea? The AI model becomes anti-fragile, and the organization itself becomes anti-fragile by using these auditors to learn and adapt its own rules in real time.
We've spent a lot of time on risks and rules and frameworks, but it is so important that we talk about the why. Why are we going through all this trouble? The answer is because the potential upside of trustworthy AI, the potential for it to help solve some of humanity's biggest challenges, is just off the charts. This is the ultimate reason for the whole field of AI trust, risk, and security management, or TRiSM.
So let's look at some real-world examples. This isn't science fiction. This is stuff that's happening right now. How is well-designed, ethical, trustworthy AI being used today to make a real difference in the world? Let's start with climate change. At its core, this is a gigantic data problem, which makes AI the perfect tool for the job. We're seeing AI supercharge our climate prediction models, making them way more accurate. There are programs, like Google's AI for Social Good, that use machine learning to scan satellite photos and automatically detect illegal deforestation. And maybe most importantly, AI is becoming essential for managing modern green energy grids, helping to optimize the output from wind and solar to reduce waste.
AI's impact is also incredibly clear when disaster strikes. In the chaotic aftermath of an earthquake or a hurricane, information is everything. AI can scan satellite images in seconds to map out damaged buildings and blocked roads, giving first responders a real-time picture of what's happening. Aid organizations are using AI to optimize their supply chains to get help to the people who need it most, faster. And predictive AI is helping us get ahead of things like wildfires, forecasting their paths to give people more time to evacuate safely.
And that brings us to our conclusion. We've gone all the way from building resilient systems to embedding ethics, automating governance, and seeing the incredible good that can come from it all.
So, let's pull all these threads together and answer that final and most important question.
So, after going through all of this, all these concepts around AI trust, risk, and security management, what is the big takeaway? What's the one single overarching idea that drives this whole thing forward?
And here it is. This is the key. This whole framework, TRiSM, it isn't about locking AI in a box or holding it back. It's about giving it a compass. It's not about restriction, it's about enablement. By building this foundation of resilience, ethics, and trust, we create the safe environment we need to confidently unleash AI's massive potential and use it to solve problems we used to think were impossible.
You know, we have the blueprint. These ideas, resilience, ethics by design, automated governance, they give us a clear path. The challenge now is really a human one. It's about getting engineers, ethicists, companies, and regulators all working together. The great work ahead of us isn't just about building smarter machines, it's about becoming wiser architects of our own future. And it's a future we absolutely have to build together. I really hope this explainer gave you a solid overview of this critical topic. Our next series is going to be diving into another crucial area, technology for a sustainable future. We really hope you'll join us for that one as well. Thank you for joining us. Please subscribe to our channel, Tech AI and Beyond, to continue exploring the future of technology.